Hello everyone, welcome to my video. This is Akhil Singh Rawat, and today I am come up with a new project of telecom fraud detection via reinforcement learning. And the this project will not, detect the fraud records only, but also tell the fraud type. So this is, a new area and new era of active, because this is reinforcement learning, as you know that it is a active learning, and machine learning and ANN, that is passive learning. So this is the new era of active and intelligent defense. So what we have, let's go to the first slide itself, presentation slide. We have dual RL agents, means two RL agents, reinforcement learning agents plus reinforcement learning based alerts. So the highlights are two RL agents trained on telecom fraud data. Uh, on same data, the two RL agents will be trained, and the classification will be, the first RL agent will be classify the fraud records, and second RL agent will uh, classify the fraud type, whether it's destination fraud, whether it's high risk destination fraud, whether it's PBX hack, etc. So as you have seen this in previous project also. So in that, I have built powerful models in using stacked architecture of machine learning and artificial neural network. I combined them, but the thing was that they were the part of passive learning, as I told you in the last project itself of reinforcement learning. That reinforcement learning is active learning. I gave you the example of chess, as you know that how computer in a chess game or any other game, how the computer outperforms you. This is the way that they are being trained for every move, and that's why they learn via trial and error method. That's why I have showed trial and error. So reinforcement learning is all about trial and error. Please watch that project of credit card fraud management if you want to understand the methodology and ideology of this. So let's move ahead. So the highlights are, the main thing is that first RL agent will tell this record is fraud or not. The second RL agent will tell that what type of fraud it is. Okay, I already told you. So what is the final decision? There is no final model. This is not a stacked model. This is the final decision will be agreements from both model. That's why the picture is there. You can see two RL agents shaking hands, and one is giving, one is showing the thumb is up. So the final decision will be when the both agrees that this record is a fraud record, the first RL agent of fraud record and second RL agent of fraud type. When they both agree, then this the final decision will be treated as a fraud. So that is very crucial thing, because I struggled in that machine learning or ANN model to create this type of model. But in reinforcement learning, they goes for split decision. That's why it's easy and it's effective. So deep learning techniques are used, reinforcement learning. So this is new level expertise in fraud management. Why? Because no one has done that. No fraud vendor till now has gone for deep learning, and particularly for reinforcement learning, because this is very tedious to train them. They're very stubborn models, I told you. So high level and intelligent fraud alert generation we will see ahead. Very in depth analytics has been performed via these fraud alerts, in designing of these fraud alerts for even a fresher or a new trainee can understand, because everything has been done by the model, and I mean the modeling, data modeling, and the automation. And they have to give just forward it to the concerned department and customer, or uh, company, to check whether these records are fraud or not. They just have to confirm that. That's it. So next. Okay, so yeah, Next slide. So what happened? What is this slide saying? That from reactive to active, the limitations of traditional models. Okay, so the thing is that I told you that traditional models like machine learning and neural network, they learn from history. They are passive models. They cram the data, and when they analyze past data to find patterns and then flag it as fraud or not fraud. So once trained, the model rules are fixed, and it can struggle with new unknown fraud types. That's why I in the last that I will show you now that in the final at auto threshold project video, I showed that this ML plus NN model, but that was only fraud type model. That's why it was giving significant results. Because if I combine this one like RL agent plus RL agent binary fraud I mean RL agent fraud records plus RL agent this fraud type, then they were having problem, because then they were not able to detect some new pattern. Okay, we will explain, we will see in production part. So the new approach is reinforcement learning, learns from experience. Our RL agent interacts with data and receive feedbacks, as I told you, rewards or penalties on their decisions. If their decision is right, then the rewards are there. If the decision is wrong, the penalties will be applied. And this is dynamic and adaptive. This is form of active learning that allows the system to continuously improve and anticipate new fraud patterns in real time. I have explained this. Let me show you the records first to give you a brief idea. Okay. Okay, so this is the training data. The training data is very small. Let me just highlight this two columns. Okay, so what's happening is, our first RL agent will be trained on uh, this alert column. This has binary values of 0 to 1. 0 stands for not fraud, and 1 stands for fraud. And the second RL agent will be trained on this column fraud type, which has I will show you, which have four fraud types and not fraud record. So see here, if I unselect normal, there are four fraud types: destination fraud, high risk destination, overlap, and PBX hack attempt. Okay, okay. So yeah, so the thing is like that, because the data is very small. You can see here only caller number, sorry, destination, minutes, call start and time is there, and that's an fraud type alert and threshold. This threshold was last time what was the threshold to generate alerts is there. That's why a number of feature engineering is being done: average call duration per color, average call duration per destination, and many more, because we have to train the model on that way. That's why that's how they learns. So the same procedure I gave to ML plus NN model, stacked model at that time, same I have fetched to these RL agents, those feature engineering. That is very essential part. So okay, so now you understand when the RL first LL, agent will say that these are the fraud records that I have select like one value, and then if the fraud type RL agent will say that yes, that he was also confident with the same confidence level, then only the fraud record will be classified as fraud. So why? Because this is part of active learning. So these records, same records, but different target are there for both models, have gone like 200 times. Let's say 200 times in front of them. So firstly, these if I remove the filter. So firstly, this model was learning like this is fraud, this is not fraud. Randomly, it is making guess. But after some time, when it notes down that my decisions are going wrong, then it analyzes why they are wrong. So in memory, it has been noted like the features are not there. But I told you like average call per duration or average call per color, and sorry, average call per destination and average call per caller, they are affecting my decisions of fraud or not fraud. Similarly, this model will learn that how to perfect in detecting the fraud type. Should not say that to normal for normal record, it will not say that it is high risk destination, or even for different fraud type, it will not say that this high risk destination is overlap call fraud. So I have trained the model in a very very effective way, because you need to formulate the policy, the reward policy, and the penalty policy. That is the main thing. And once they learn, and they they start their performance start upgrading. Okay, so next. Okay, so let's move to the next slide. So this is the core innovation, a dual RL agent system. So I'd already told you this part. Agent 1, the fraud alert agent, its goal is to make a simple binary decision: this record is fraud or not fraud. Again, the fraud type agent, it specializes in classifying the specific type of fraud, like in telecom, there is sim boxing, subscription fraud, many other frauds. We can train on any fraud. The crucial agreement, the record is only considered a high priority final alert when both agents agree, I told you. So this is a very powerful filter, and that minimize false positive. The agreement should be there. That is the main thing. Okay, let's go next. Okay, so next slide. This is the strategic advantage. Why this is a breakthrough. Uh, as I already told you that old method that you can see here, that is reactive, means passive, static, and higher false positive. So our solution RL agent is the crucial agreement between the both. So this is proactive detection. What the dual agent agreement is a, again a very crucial mechanism, because our final alerts are just not accurate, but they are highly reliable. So as I told you, this is a active learning, and the system checks and balances that ensure our final alerts are not accurate but highly reliable and minimizing false positives. And basic thing is that reducing false positives, we are not even saving time, and we are we are cut down on irrelevant alerts, I mean, and then we are saving ample time and resource for human analysts. Because the main thing is then in operation that a wastage of false alerts. So when there are very high very less false alert or zero false alerts, then only the efficiency of human analysts will be at very high level. So this is very high level expertise. This project demonstrates deep expertise in reinforcement links. Only expert level data scientists or even developers can make this. This is a cutting edge field in deep learning. This is reinforcement learning. I have to tell you that this is really a very very high level. So next. Okay, so here we are. Uh, Before going to prediction and that alert generation phase, I want to tell you that what is the difference. So this is the code, final code for two reinforcement learning model, alert plus fraud type, and here it is. This is the that code from the auto threshold project. So can you see that how many ML models are used? Random forest, gradient boosting, extra tree, cat boost. So these are base model one. So all these will make decision, and then final model logistic regression will make decision based on their decision. On other side, MLP 1 plus 2 plus 3 4, MLP means ANN models are there, and then their decision will be fetched to logistic regression. Then logistic regression will make the final decision, and then again from base one, I mean from uh, the set of base one and final meta model will make decision, and set of base two plus final meta model will make decision. It will pass through again to a final model that will make the decision. So that's why it was very very calibrated, so well calibrated, and again I have fine tuned it. So now even we don't need that auto threshold function. I told you now that the threshold of zero point 0.5 has to work. the model has to throw the higher probability fraud records towards the higher fraud probability, and not fraud records towards the lower fraud probability. And just I will show you now. Okay, so you can see here now, that is that machine learning plus NN model. You can see here base model 1, I told you, random forest, extra tree, gradient boosting, cat boost, and base model 2, set of base model 2, MLP classifier 1, 2, 3, 4. See, I was not making this up. And meta model 1, logistic regression, meta model 2, logistic regression. So initially, so many models on both sets, then two final models, and then again their combined prediction will go again to a final model that will make prediction. So you can see here, uh, combined prediction is equal to prediction 1, prediction 2, and there is a function that will this combined prediction will be placed in this, and then logistic regression again will make a final decision on this combined predictions. So that's why it has been calibrated so well. And even I have done cross validation. So okay, see here. So there is a for RL agent one. This is our binary model, RL agent one model. So this is the model path, and this is our second RL agent, the fraud type model. So that's why this fraud type model path. Okay. So now we'll tell what the problem happens. See, this is our training records. Okay, if I put a filter over here, and if I select fraud type like destination fraud, see, the destination fraud have these records of Angola, Bulgaria, Cuba, Albania, and 4,000 minutes something, 1,000 minutes something call, again 1,200 minutes something call. So these all initially all calls are over 1,000, and this is a incoming new record file. See, this is a simple record file. This will be given to the model, to both prediction models. So what happens is, when I was combining machine learning and ANN model, like I have made two RL agents when I was making two machine learning or ANN models separately. So when they will identify this, because this is 1,000 minutes call, this is 3,000 minutes call, all are both over 1,000. But what happened with this 900-minute call, they were skipping that, because that's what problem was there. They cram the data. This is new pattern 900 the record I put here is to bluff them. Okay, this one France. So that's why I made this only as a fraud time model. So I don't need them to be like our legend two models. I made them only fraud time model because they were failing there. So that's the main thing. I have to tell you that but this RL agents will not fail, because first RL agent itself is caughting this fraud, then only second will tell that I that he is also confident. The second RL agent is also confident on classifying this as fraud. Then it will tell what type of fraud it is. So that was initially a problem with ML and ANN models. Okay, let's go to production part. We will compare now. Okay, so we will check both model predictions. See, there is that file, incoming record file, call cdr new. If I hit the run button, so the code has started running, and you can see here, but it is trained on live data. I means training data, but training model file has not been saved, but yeah, results are there. See, this much records were initial predictions. I mean, these were records are initial that model predicted on every record. See, not qualified. Why? Because I have given threshold of 0.5. less than 50% will not qualify. So see how perfectly calibrated, 37%, 29%. So model was not able to find high probability equal or greater than 50%. So destination fraud, this is qualified by 85%. Destination fraud 79%. Overlap call fraud 72%, 72%. And for which 2728 index number. So 2728 index number is this one, same number for overlap called. So lastly it will show final prediction. So these are the records that qualified. One is the same color number for two records, overlap call fraud. So in the overlap call fraud, two records are being recognized. One is ongoing call, and in between second call started. So for destination fraud, this much. See, 3977 minutes, 1123 minutes. So these are destination fraud. And for the same file, if I have already placed that same file, so RL agent has to do the same. But when RL agent makes the decision, then this is highly reliable that it is fraud. Because why? It goes for split decision. See, what a beauty. Though only those four records, two same color number for Benin overlap call fraud, and then Myanmar and Somalia again same. 1123 and 3977. Okay, so next now we will go in alert generation quickly. So here we are. So this is a complete code alert model plus four type model of RL, reinforcement learning agents, two RL models, and then email alert generation. So okay, and let me hit this button. So we have our C. Uh, I will show only for one dataset. Only the final dataset has been made, and alert has been sending live. So wow, see now it's coming live in front of you. I was already cleaned the inbox for clean and perfect view for fraud alerts. See P1 RL based alerts. Let them come. Let them come. Then only we will check the whatever what is the high level analytics and what is the intelligent alert generation designing, I mean. Okay, so I believe I will check now. The code has stopped now. Yeah, right. So generating and sending alerts, these were the records find. What happened in alert generation is that I have made an adjustment that how to group them according to the fraud type. So now we will go and check. So let's check with the destination fraud itself. See, so again Cuba. So here if I show you that this one is for Cuba. I told you destination fraud 1123 minutes, same alert for 1123 minutes. So P1 RL based fraud alert, this calling number, fraud type detected, destination fraud. Wow, see what well, I mean this has been caught, I mean detected as a destination fraud correctly. So dear user, this is RL based fraud alert for destination fraud with high probability of fraud. Here are details. So these are details. This number is make call to destination Cuba as a long duration call. Total approximately 18.72 hours, 0.78 days. So I was telling you about this. Even a new trainee or fresher, when this type of insights are given, even a layman can understand this is a very long duration call, man. So this is, even you can see here, this pattern is highly indicative of continuous automated fraud. So we have put the even the information as well as per fraud type to make the human analysts work very easy. And when even the records are there and fraud type destination fraud. So see, RL based system disposition for this alert is fraud. Destination found in alert for these caller numbers are temporarily barred. So the decision, automated decision, automated action has been taken. This is up to management what they want to do. They want to do temporarily bar the services, but the I think the practical way is to bar the destinations temporarily. Then even human analyst can verify with the customer or the company PBX vendors, or even with the companies that have the connection. So this is the plot itself. Call duration per day for destination Cuba. See, if I click this now, I told you this is very high level analytics. As a fraud and manager or a data scientist, you have to give to your team. I mean, analysts who are working online for on these alerts. Call duration per day for destination Cuba. See, for 23rd December, the this was done. 1123 minutes were called, and that was Friday. So the insights are there, whether it's a weekend or not, because in weekends the mostly probably the more fraud happens, because they know that PBX companies, their employees will not be there. Very few employees will be there. We can target. So even the additional info is there. Repeated long duration calls to a single destination suggest automated routing or misuse. See, so when human analyst, even I told you a fresher or a, new trainee will check this and read this, then it will understand also that what that training, the for training that he or she is going. So they can know that even our fraud manager or data or our backend team has done this for us. RL agent verdict fraud. Okay, so this is a continuous learning. They don't have much to do about that. The learning itself is there from them, because why? Because the destination found in these alerts are temporarily barred, so they need to confirm these for customers only. Then again, this destination fraud, I told you that France as well. So that the 900 minutes call was not in training records, but then also the fraud records, I mean fraud, binary fraud agent has, RL agent has caught. And then also fraud type agent was also find an agreement that yes, this is according to me also, fraud type also, I mean this is fraud. So call duration per day for destination France. So the alert for this caller, France has a long duration call approximately 15 hours. Who does that? This pattern of highly indicative continuous automated similarly, same additional info is there in the plot itself. And third one is for Australia. C. Australia's caller number for Australia has long duration call. I mean this alert for caller. Totally approximately 66 hours. Now this call went for more than 2 days. I mean 2.76 days according to the data. So what happens is that now this plot is showing a much more clear picture. See, RL agent verdict fraud already destination has been barred. You can see here on 23rd December start Friday it started with that day 9:48 minutes of calling. Saturday and Sunday whole day calling 414 the 1440 minutes means 24 hour of calling, 1440 again 24 hour calling. Then on Monday it went for 148. And then initially then after whenever the call was cut, so records were made and they passed through the switch, and then it come to the fraud vendor, I mean the system, and the system has taken action. See, RL based system is fraud destination found in this alert for these caller numbers are temporarily barred. So yeah, I told you that is very high level, analytics and high level. Now we are seeing the fraud type is high risk destination and the Guinea-Bissau. Okay, so what is saying? This is RL based fraud alert for high risk destination with high probability of fraud. Here are details. This group of calls have a cumulative duration of this much hours, 13.38 hours, around about more than half day to the destination Guinea-Bissau. The similar call volumes across same destination suggest coordinated behavior flagged by the RL model. So what the learning also there. So this is what high in depth alert making has been done. If I click this plot now again, see total call minutes for high risk destination Guinea-Bissau, and see this image is saying on its behalf that these three callers have a very similar pattern. Why? because they have made a single call to high risk destination Guinea-Bissau, and even the additional info is there. You can see here distinct numbers calling to high risk destination with same intensity is indicative of fraud scenario. Oh, I mean, I don't know if someone is new on the first day of training, he can also, he or she can also tell that, man, this is a beautiful, beautiful automation. The use of deep learning and automation done by our manager, done by our backend team. Wow. Let's see these type of fraud. PBS hack attempt. Okay, wow. See, this is RL based fraud alert for this number. Fraud type detected. PBX hack attempt. So this is hack attempt not complete. These are two different rules. This is RL based fraud alert for PBX hack attempt with high positive probability of fraud. Here are details. This alert for caller number. This shows a series of short calls made during nighttime hours. So what's I told you that, a high level analytics, high level, this alert making has been done for designing this. So this pattern is typical of PBX hack attempts where attackers test outgoing service status during low traffic window. Wow! And if I click this plot, then you can see here Latvia is destination for three calls, and nighttime, and with the single caller number. Call duration for PBX hack attempt by caller this much. A series of short calls suggest PBX hack attempt before PBX hack complete alert will fire. So what it is saying that, next time, uh, before the hack complete, alert will fire. This they test with the short calls to whether this outgoing services are, active or not. So these are record itself. The RL has, system disposition of this alert is fraud. Destination found in this alert for these caller numbers are temporarily barred. See, the action has already taken, and the learning and, perfect, message conveying is there for human analysts. Very, they don't have to do just verifying the status. Everything is being done by this deep learning and automation. See, again, for this previous attempt for this number, RL agent verdict fraud records are there, and even the, explanation and learning is there. And the last fraud type, overlap call fraud. We will check this now. Wow. RL based fraud alert for this caller number, fraud type detected, overlap call fraud. This is RL based fraud alert for overlap call fraud with high probability of fraud. Here are the details. So this shows calling overlapping call for this. Destination labels and timings are shown for clarity. If I click this now, you can see here this caller number has called to Benin. If there are two different destination for two records, then another will be added here. Current call, previous call. So this is previous call. This is the whole time frame you can see here. If we see the records here, see. So 351 call started, 451 call ended. In between, you can see here 451 call ended. In between this 415 call started. See, this call was going on in between this call started. So that's why the time frame is there from 350 more than 1 minute ahead, 351 till the whole call went to what is the more, I mean, one is the, for sorry 451 is the main call and time of the whole time frame. So from 351 till, 451 call went, and in between, this one, current call started, that started from, you can see here 415. So here after 410, here 415 the call started. So what a beauty. Even you can see here when, if somebody clicks on the plot itself, the additional info says these patterns often suggest call misuse or routing anomaly. It can be, a routing anomaly from the mobile company switch, where it should not be happening, because in this rule particularly we drop call conference calls, and a call hold calls, call wait calls. So that's why it shows the pure call. This should not be happening, but it happened. So it might be problem with the switch itself, that, somehow user was able to make second call before the first ended. Okay, so yeah, and then again, fraud type overlap call fraud. Destination found in these caller numbers are destination found in alert for these call numbers are temporarily barred. This is up to the management if they want to bar, the outgoing services, particularly, or only the destination. Like even if PBS attempts the this is better way that outgoing services should be barred if there are multiple alerts like this. Hack attempts for uh, I mean, after PBX hacked them, the PBX, this one also fires uh, the hack complete. Then it will prove that it have long duration calls. Even these are short duration calls. Then even long duration calls are there. Then and the intensity will tell that the hack has been completed. So it's up to the management decision, but I have shown you very very high level, very very high level implementation. So okay, next. Okay, so what's happened next will be the future of fraud management is that we will make a generative AI assistant. I mean, we will integrate a large language model to assist human analysts for the decision making. That will be based on using RAG, retrieval augmented generation system. They will retrieve the information, then augment it, make precise, and then generate according to the queries asked. So the thing is like that. It will make ease for this human analyst workflow, because even they can answer a complex question, that it will check in CRM, and it will check previous history, that even that doesn't it has a human analyst has to do, because it will just ask, does this caller history match the current calling pattern. So sometimes what happens is somebody is calling to high risk destination, also Guinea-Bissau or Latvia. They tends to be Latvia national or Guinea-Bissau national. So if they have history, we don't have any problem with that. So that LLM will tell itself, and then for even if there are no matching history or new destination, new subscriber is there. So what are the top high risk destination this week? This question can be asked to the large language model, and it will show that these are the top high risk destinations. So if some new subscriber is making frequent or high level, I mean a high count of calling, then human analyst has make a quick decision about the action. So we will do this seamless integration. This system will create a new workflow that, as I told you, with our powerful RL alerts, with knowledge and reasoning capability of generative AI. Generative AI will be used to in this LM model to make it fine tune in a effective manner. So that's it from this project. I believe I was able to convey uh, whatever the highlights. And now Akhil Singh Rawat signing off. Please take care of yourself and have fun. Bye bye.